This is Mrs. Huntley. This is Module 3, Lesson 2, Properties of Dilations. You should be on page 9 of your workbook, and your essential question for this lesson is, what are the properties of dilations? You will need a ruler for this lesson, and we're going to get going. The first question, make a conjecture about how dilations will affect lines, segments, and rays. Okay, here we go again with the properties where it has that repetition thing going on. Well, remember in last lesson, we said that there's a multiplicative relationship between the original and the dilation. So whatever the scale factor is, everything is being multiplied by that scale factor. So a line, segment, or array will still be a line, segment, or array after it's dilated, but the length of the line, segment, or array will be changed proportionally according to the scale factor. In other words, all of them are going to be multiplied by the same scale factor. What about angle measures? Angle measures are not going to change. Whatever the measure of the angle was before the dilation, it will be exactly the same after the dilation. So let's go ahead and get started with some dilations. Here's where you need your ruler. Example 1 says find P prime and Q prime. They took away the direction, so I'm just going to add some back in. Dilate points P and Q by a scale factor of 2. So our R, remember we said we were going to use R for the scale factor, our R equals 2. Now I'm just going to write our rule here. So the dilation, so we'll call it OQ to start. So OQ prime is going to be equal to our scale factor times the original length of OQ. That's our rule that we're going to use. So what I'm going to do is I'm going to draw a line from our center of dilation through point Q and beyond. Mine happens to be orange. I'm not exactly sure why. I never put it on orange, but there it is. Okay. So my original, I'm going to say OQ prime is going to be equal to my scale, equal to R. R is 2 times my original length from O to Q. It looks like I'm right at about 4.5 centimeters. So 4.5. So 2 times 4.5 is 9. So OQ prime is going to be equal to 9 centimeters. Make a dot at 9, and I'm going to call it Q prime. I'm going to move my ruler to go through point P. Come on. And beyond. And again, I'm going to draw a line from my center of dilation through point P and beyond. So OP prime is going to be equal to R times OP. R is equal to 2, that's my scale factor. And OP, the original length of OP is 3 centimeters. So OP prime is going to be 6 centimeters. So I'm going to make a dot at 6, and we're going to call that P prime. I'm going to move my ruler real quick so you can see what this dilation looks like. And then I'm going to go ahead, you can use your ruler to do this. I'm going to draw a line, but I don't want it orange anymore. I'm going to just do a black line from P to Q. Actually, I'm going to make that a little thicker because it's kind of blending with the background. Okay. So I've got my line from P to Q, and I've got my line from P prime to Q prime up here, and I've got my line from P to Q here. I hope you're noticing that we've got parallel lines here, and they're cut by a transversal. When I have parallel lines cut by a transversal, remember all of those angle relationships that we learned in the last module. So this inside angle here at Q prime is going to be congruent to this one at Q because they are corresponding angles. Same thing with this one here at P, at P and P prime, corresponding angles. Now O is congruent to O, so I've got a triangle here and a triangle here that have all the same angle measures. That right there will tell me that these are similar triangles. Not to mention that my side lengths have grown in proportion. Okay, so I know my triangles are similar. Let's move on. This one is asking us to grow, oh, I forgot to take this away. This is not the first time I'm recording the video, can you tell? This one is asking us to grow by a scale factor of 3. So again, I'm going to do the same thing. Draw your lines through the points and beyond. OQ prime is equal to our scale factor of 3 times the original length. OQ looks like it's right around 3 centimeters. So OQ prime is going to be equal to 9 centimeters. 3 times 3 is 9. That's how I'm coming up with that. So this is going to be my Q prime. If you are comfortable right now, you can pause the video and see if you can do this dilation on your own and get a similar triangle just like I did. So OP going to be equal to 3 times, looks like about 2.5. So OP prime it's going to be about 7.5 centimeters. Okay, take my ruler away. Actually, you probably need your ruler to make this last line. But I have my handy dandy line drawing tool. Again, I've got my parallel lines. I've got this triangle, so OPQ, and then I have OP prime Q prime. So I have similar triangles because I've got 2 parallel lines here. Now it should work that if I measure my lengths of P and Q and P prime and Q prime, they should also grow by a scale factor of 3. I don't want to take the time to do that right now because this lesson is a little bit long, and the first time I recorded it, I was really bumping up against that 20-minute mark. So I want to make sure I get through all of the examples. But if you have the time to go ahead and measure PQ and see if P prime Q prime is 3 times as long, that would be awesome. So our next example asks us, what if my center of dilation is on the same line as the points that I'm dilating? Let me just get my ruler turned around here and put the 0 on my O. This is a lot trickier than I thought it was going to be. There we go. All right. So OQ prime is going to be equal to our scale factor. Let's do a scale factor of 2. So scale factor times the original OQ. So OQ looks like it's 2.567, 2.7 centimeters. 2 times 2.7 is going to be 5.4. So OQ prime is going to be 5.4 centimeters. Okay, I'm going to take my ruler away. And I want you to notice that O, Q, and Q prime are on the same line. What do we call it again when something's on the same line? We learned it last module. Collinear. Okay? So when the center of dilation is in line with the points being dilated, all the points will be collinear or on the same line. Same thing will happen with P. If we measure OP and we have P prime, it's going to be out here. And what's going to happen when your scale factor is 2, whatever this measurement is going to be twice as long. So this length, OQ, is going to be the same length as QQ prime. Hope that didn't just confuse you. Okay. What happens when we have a scale factor that's less than 1? So let's take a look at this here. We have our points A and B, and our scale factor is going to be 1/2. So OB prime is going to be equal to our scale factor of 1/2 times the original length of OB. OB looks like it's 8. 1/2 times 8. So B prime is going to be at 4. I'm going to move my ruler. Come on. go. And check AB, OB, or OA, sorry. So OA prime is going to be, again, our scale factor, 1/2 times the original length of OA, which it looks like it's going to be about 4.567. Let's go 4.8. So 1/2 times 4.8 will be 2.4. So OA prime is going to be 2.4 centimeters. That's going to be my A prime. I'm going to move my ruler, draw a line through AB prime. And again, you'll see I've got similar triangles, parallel lines cut by my transversals, so I know my angle measurements are going to be congruent, and I've got similar triangles when I've just dilated those points. Oh, these were supposed to be rays. I forgot about that. The arrow was cut off because I just noticed that the question said, what happened to our ray? Is it still a ray? Yes, it's still a ray. It's always going to be a ray. Whatever it was before you've dilated it, it's going to be the same thing after you dilate it. It's just the length of it is going to be changed by the scale factor. All right, next they want us to dilate an entire shape. We still have our scale factor here. Or I'm sorry, our center of dilation, and they're giving us a scale factor of 3. So let's go ahead and get our ruler, and it's already set up on the right angle to put a line through C. So I'm going to draw a line. I want to make sure my line is black though, because I don't want a weird color, and I want a skinny line. Okay, so starting on my center of dilation, I'm going to draw a line through C and beyond. Okay, so OC prime is equal to our scale factor of 3 times the length of OC. OC looks like it's at 4 centimeters to me. So OC prime is going to be 12 centimeters. I'm going to come up here to 12, make a dot, and we'll call that C prime. So what I would like you to do now, if you are comfortable, is go ahead and dilate point B and A on your own. Again, doing the same thing we've been doing, starting at the center of a dilation, drawing a line through the point that you're dilating and beyond, and then OB prime is equal to the scale factor of 3 times the original length. We're looking at about, looks like 4.6 to me. So 3 times 4.6 is 13.8. Now keep in mind, I'm using an online ruler. I don't know how accurate mine is. So if you're getting a different centimeter, like if yours is giving you exact numbers and you're like, it's exactly 4 in my book, Mrs. Huntley, what's happening? Just keep in mind that my picture might be distorted. Your measurements might be slightly different, but they should be approximately the same size and shape. It should give you an idea. So we're 13.8 centimeters, and this is B prime. And then I'm going to move my ruler to do A. So OA prime is equal to my scale factor of 3 times my original length, which looks like it's about 3.4 centimeters. It should be about 10.2. 10.2 would be right here. That's going to be A prime. Now I'm going to move my ruler. Again, you might need to keep your ruler because I need to connect all of my segments. So since C and A are connected here, I need to connect C prime and A prime. So I'm going to do that with a nice blue line. So C and A. Then C and B are connected, so C prime and B prime need to be connected. And then A and B are connected, so A prime and B prime need to be connected. And you will see I created a similar triangle here. Now I should be able to measure CA and C prime A prime, and they should be growing by the same scale factor. I do believe our directions are telling us to do that, so I'm going to grab my ruler and see if I can get a measurement here. Okay. See, and I hope that it didn't mess you up in the earlier part of the lesson. I know when I did this on pen and paper, CA was 3 centimeters, and now it's showing me that it's about 3.3 centimeters. So mine is probably off from yours as far as my numbers, but again, the drawing should look about the same. So I'm looking at about 3.3 centimeters, so CA. I'm just going to make a mark over here, 3.3 centimeters. So 3.3 times 3. I'm going to expect C prime A prime to be 9.9 with my scale. Again, yours might be a little bit different than mine, but when I'm measuring mine, I'm right at about 9.9. So again, everything has grown proportionally. So let's take a look at the questions here. See, I filled this out before, and let me check AB and see, because I did it on pen and paper before I started recording the video, and I just want to see how close it is. Oh my gosh, making me crazy. So I'm going to put 0 on B and then rotate this around. Okay, good. It's about 2 centimeters from B to A, or yeah, from B to A, we're looking at 2 centimeters. So B prime to A prime, I'm going to expect it to be 6 centimeters. And that's working out for us. So the length of AB, or the length of AB like that, is 2 centimeters. A prime, B prime is 6 centimeters. BC 5.2, I'm sorry, BC 1.75 centimeters. BC prime 5.25. CA, I see again, that was 3 centimeters exactly, 9 centimeters, and everything was grown by a scale factor of 3. It's still being grown by a scale factor of 3, but my ruler is off a little bit. So I believe that gets us, okay, if we measure angles A, B, and C, they're going to be the same as the pre-image was. The degrees of the angles do not change when the shape is dilated. And that brings us to the conclusion of this lesson. Let me summarize super quick for you. So dilations map lines to lines, segments to segments, and rays to rays. Dilations map angles to angles with the same degree, but the lines, segments, and rays grow proportionally by the scale factor. Hopefully this lesson has made sense to you, and I will see you tomorrow morning. Thanks. Have a good night.